Hello and welcome to another LeetCode problem. Today we're going to be doing problem number 50, power. And in this problem we're trying to implement power which calculates x raised to the power n. And so here, let's go through our example. So first we have 2 to the 10th, and that's going to be 1024. Then in our second example we have 2.1 to the third, which will be 9.261 according to this. Then finally we have 2 to the negative 2, which will be 1/4 or 0.25. So we're trying to do this without actually using the exponent, right? Because that would kind of defeat the purpose. So you can't just call 2 to the 10th. We're trying to implement power without actually using a power. We're trying to use multiplication or whatever other stuff we have. And so what's one way we could do this? Like, let's say we're just trying to do 2 to the 10th. How could we do this? Well, we could do like a recursive or a while loop, where we could just say like, while this isn't 1, then let's just do something there, right? So that's going to be pretty straightforward. And we could just say like, okay, well, it's not 1, let's just do 2 times 2 to the 9th, right? And then 2 to the 9th can be 2 times 2 to the 8th. And this can be 2 times 2 to the 7th, and so on. So this would actually be linear time, because we're just taking out the base every time, and we're multiplying the base by whatever is left until the exponent is finally 1. So that's not an efficient solution. Let's try to get something better, right? Essentially. So if we have 2 to the 10th, can we do better than linear time? And we absolutely can. And the way we're going to actually do this is going to be pretty straightforward. So let's say we have 2 to the 10th. What we can actually do is we can calculate 2 to the 5th. So we can calculate 2 to the 5th. We're just going to take n over 2, essentially. We're going to calculate that value. We're going to store that value. And then we're going to multiply it by itself, right? So we can do 2 to the 5th times 2 to the 5th, and we're only going to calculate this one time. And that'll give us 2 to the 10th. And then how do we break down this 2 to the 5th? Well, it's pretty straightforward. We're going to divide this by 2 as well. So we're going to say, let's just say that's 2 squared times 2 squared. And then because this is odd, notice we need to add a 1. So it's going to be 2 squared times 2 squared times 2. This is going to be the same exact thing. But we only need to calculate one of these, and then we're going to store it in a variable. So this is going to be in a variable. And then we're just going to multiply by itself, essentially. So for our rules are, if the exponent is, let's just have like our base cases and stuff, so on, right? So for our rules, if the exponent is 0, what do we want to do? We want to return 1, right? Because anything to the 0 is 1. Now our second base case, if the exponent is 1, we want to return n, or whatever that number is, right? Because like 2 to the 1 is 2, 100 to the 1 is 100, and so on. So these are two base cases. Now let's go to our other cases. Anything else, let's calculate the base to the exponent divided by 2. Then let's multiply it by itself. And then finally, if the exponent is odd, multiply by base. And let's just show you why that is, right? By base. So this is going to be pretty much our rules for our recursive case, but let's just show you once again why this is. So if we have 2 to the 5th here, if we divide it by 2, we get 2, right? If we take this exponent by 2, we get 2. So then we're going to get 2 squared. We're going to calculate that value. So we're going to calculate, we're going to store it. We're going to multiply that by itself, right? So by 2 squared. And notice to get 2 to the 5th, we actually need to we need to multiply by the base again. But if we have 2 to the 4th, where if this is even, then it's just 2 squared times 2 squared. And so if the exponent is even, you just calculate 2 to the n over 2. And if it's odd, you do 2 to the n over 2 as well, but then you need to multiply by this to get that extra odd. And so let's just show what that's going to look like for this 2 to the 10. Let's just break all of this down. Let's just show you how this would work for 2 to the 10. Okay. So let's say we have 2 to the 10 here. And we are in our first recursive case. So we're trying to get 2 to the 10. And we're going to calculate 2 to the 5. Okay, we're going to calculate this. We're going to store it in a variable, and then we're going to multiply it by itself, right? So 2 to the 5. So we're only going to calculate this once. We're going to store it in a variable, and then we're going to multiply it by itself. So we're going to do 2 to the 5 times 2 to the 5. Okay. Now, this 2 to the 5 is going to recur, so let's just draw this in another color. And remember, we're only calculating one of these, and then we're multiplying by itself. So how do we calculate 2 to the 5? Well, it's going to be 2 to the squared, and then we need to multiply it by itself, right? So we're going to store this value, then we're going to multiply by 2 squared again, and now finally we are going to multiply by 2. So that's how we get 2 to the 5, and then this would go back up, and then we would just store that and multiply by itself. And then 2 squared, how do we do that? Well, that's pretty straightforward. It's just 2 times 2, right? So 2 times 2. And notice we only have to calculate the left side for one of these because we're gonna calculate the left side and then store it and then just multiply it by itself. So we're not doing 2 calculations here. We're doing 1 and just multiplying by itself. Okay, so 2 squared is going to be 2 times 2, which recursively is pretty straightforward, right? We would just calculate, 2 to the 1, which is one of our base cases. So we're just going to return 2 here. And then that's how we would do that. So we just get 2 to the 1 here. This would be a base case. And then, like I said, we don't have to calculate this because we're going to calculate this. So there is one more thing here. And that's what if we have something like exponent is negative? Let's take a look at that. So if we have like 2 to the negative 2 is an easy one. Or negative 3, let's say. So any number to a negative exponent is going to equal 1 over 2 cubed. So whenever we have a negative exponent, we can just recurse, and let's return 1 over, this whole power thing. So it'll be like 2 to 2 cubed. And then we can calculate this in a normal way, right? Like we can calculate this doing our normal steps. So if our exponent is negative, let's return 1 over the recursive case here. And that's how we would get rid of the negative exponent. So we have 0, we have 1, we have anything other than negative, right? We're just dividing our power by 2 every time. We're multiplying it by itself. And if the exponent is odd, we need to multiply by the base 1 more time. Because if it's like 2 to the 5th, we need 2 squared times 2 squared times 2. Same thing if we have 2 to the 7th, we would need, 2 cubed times 2 cubed times this extra 2. Where if we have 2 to the 6th, it would be just 2 cubed times 2 cubed. Okay? So what's going to be the time complexity here? It's actually going to be logarithmic because we're starting with 2 to the 10th, and at every single recursive case, we're going down, we're removing half the power, right? So it's going to go like 10 to 5 to 2 to 1. So this is logarithmic. Okay. And we can also cache, but I don't think it's going to matter. So I guess we can throw in a cache, but I don't think we're doing any repetitive work. So I don't think it's necessary because we're just calculating one of these and then we're using that result to get everything else. So I don't think we actually need to cache because we're calculating one of these and then we're like the values that are together are going to line up and we're only using one. So I don't think we need to cache in this case. You can correct me if I'm wrong, but I'm pretty sure that's the case. Okay, so let's actually start coding. So what are our base cases? So if x equals 0, we can just return 1, right? That's pretty straightforward because anything to the 0 equals 1. If x equals 1, we can return the... in this case, n is the exponent. So if n is the exponent, then we need to return x because x is the base here. Okay, now if n is less than 0, meaning it's n negative, just return 1 over, and then we can just call this recursively, right? So this would be like self my pal x negative n, right? We're just going to say, so if we have like 2 to the negative 3, let's just return 1 over 2 to the 3 essentially, because that's going to be equal. Okay. Now for our other case, we're going to have temp equals, this is going to be self my pal x to the n over 2, right? We're taking the power, dividing by 2. And then we are going to say, let's just say temp equals temp times temp. So like if we had 2 to the 5, we would calculate 2 squared here, store that in temp, have temp multiplied by itself, so we get 2 squared times 2 squared, and now our temp would be 2 to the 4th. And so finally we need to do one more thing, right? So we need to return temp if n mod 2 equals 0, meaning the base is even, but for this case we need to multiply it by the base one more time. But if we had 2 to the 4th, then it would just be 2 squared times 2 squared, right? So it'd be like this. So if it's even, we can just return temp squared. Essentially, this is just temp squared without using the power. And otherwise, we need to return temp times temp times the base one more time. So if this is even, we do this, else temp times x. Okay, so let's try that. Okay. Okay, so it actually passes and it's quite efficient. And yeah, I don't think you need caching. We can test for caching. So we have 39 seconds of runtime. We can test for caching, but I don't think it's gonna help at all. And how do we want to test for caching here? We'd probably want to have like, I mean, I think you can actually just write cache here as like a simplified version, and I don't think this will help at all. So let's see. Yeah, like I don't think it's doing anything. Like I said, correct me if I'm wrong, but like I don't think a cache does anything in this case. Okay, so we're gonna go with the solution. And let us go over the time and space here. So for time, like I said, it's logarithmic. So it's gonna be log of n, because if we have something like 2 to the 10th, we would calculate, 2 to the 5th, then 2 squared, then 2, which is logarithmic, right? We're dividing by a power of 2 every time, and we're not doing repeated work because we're just taking one of these and we're multiplying by itself. So essentially you're getting one of these and you are squaring it every time, right? So 2 squared, squared. We're not calculating this multiple times. But even if we were calculating twice, it would be like 2 log n, which is still fine. Okay, and for the space, so for the space, we aren't storing anything, but we want to think about like what's our worst case stack depth, and that's going to be log n as well, right? Because if we have 2 to the 10th, once again, our stack frames is going to look like we're trying to calculate 2 to the 10th. Now we're trying to calculate 2 to the 5th. Now we're trying to calculate 2 squared. Now we're trying to calculate 2 to the 1. So worst case, this is going to be log n of space, because we do have to calculate like the maximum number of stack frames this will take, even though we're not using any kind of cache or anything. You do also want to think about, if you're recursing, what's the worst case recursion, and that's going to be log n. In fact, I think it will always go log n. It's not going to be like a worst case, right? It would always go log n because it would always divide by 2. So it would be consistently log n space, and time would also be consistently log n. It's not going to really have a best and worst case. It's always going to run around the same time. It doesn't really matter on the input. It's always going to be around there. Okay, so that's actually going to be it for this problem. Hopefully you liked it, and if you did, please like the video and subscribe to the channel, and I will see you in the next one. Thanks for watching.